And so this is how you would solve a problem that's written in vertex form. All right, so as far as the vertex form, the reason it's called vertex form is the vertex is something that you should be able to identify without even needing to use a calculator. And in fact, you guys are going to have a quiz where you can't use a calculator, and it's going to involve finding the vertex from this form, finding the x-intercepts from the other form, and then doing some basic factoring, which we'll get to here in the next section, the next couple sections. Okay, so you do need to know how to answer this part right here by hand. Okay, what is the vertex based on this equation? Okay, and the reason this is called vertex form is your coordinates of the vertex can be easily identified based on these forms. So here, the x-coordinate of your vertex is whatever value of x would make this whole parentheses equal 0. So what would that be? -2. And then your y-coordinate for your vertex is whatever this vertical change, this vertical shift parameter is. So what's that? 1. So there's your vertex. And again, this is why it's called vertex form. You can find this very easily. It's no calculations, just an interpretation of the form. Okay? Now, the other pieces of information, and so based on this, you should be able to find the axis of symmetry. The axis of symmetry is simply equal to the vertical equation, x equals, that passes through the x-coordinate of that vertex. So it's going to be x equals whatever your x-coordinate of the vertex is. So x equals -2. So these are the two things that you should be able to get no problem without much thought. Okay, now, the other things that you need to be able to identify, the y-intercepts, the x-intercepts, and then the tendencies of the graph. Okay, so we can find the tendencies of the graph as well before we actually refer to the calculator. Is this graph going to open up or down? The coefficient in front of the whole thing is negative, so it's going to open down. So again, if a is less than 0, if it's a negative number, okay, where a is that leading coefficient, then it's going to open down. You can also determine whether this is more narrow or wider than the parent graph. Okay, so narrow means it's the vertical stretch, or it's a steeper graph. Wider means it's the vertical shrink, and it would wind up being a flatter graph. Okay, so looking at this, the way that you determine that is whether your a value, the number in front, the coefficient, has an absolute value that's a fraction smaller than 1, or if it's a value that's greater than 1. So here when we look at, again, disregard the number or the negative sign, we have a 1/4. Since 1/4 is less than, so if the absolute value is less than 1, we're dealing with a wider, flatter vertical shrink in the graph. If this had been greater than 1, then we'd have a more steep or narrow vertically stretched graph. And so in this particular case, it would be a wider graph. Okay. All right, so let's go back and see, one, how we could find or confirm all of these pieces of information using our calculator, and then also what it would involve to find the y-intercepts and the x-intercepts here. Okay, so if we were to go to our y-editor and enter this equation exactly as it appears, so -1/4 times the quantity x plus 2 all squared plus 1, hit enter. So here's my function. So I can view this in my graph window. So this is what my graph should look like. And so -2, 1, there's my vertex, it's confirmed. If I want to find my y-intercept, very easy. I simply plug 0 in for x. And so you could either do that manually, or if you've entered it on your calculator, choose the F5 Math tab, select value, the very first thing, and then type in the 0. You want to evaluate when x is equal to 0, and you get your answer 0, 0. Okay, so there's our y-intercept. Okay, and then we want to find our x-intercepts. Our x-intercepts are the two locations where for x that have a y value of 0. Okay, well, we just saw one of them, right? We see that 0, 0 is 1, so that's going to be an x-intercept as well. If I ask you for the greater or lesser of them, it just means the lesser is to the left on a number line or on the graph. The greater is to the right. So 0, 0 I can see here visually. That's my greater solution, or 0. So if I want to find the other one, I could use my calculator in this graphing utility. I can go to the F5 Math tab again, choose 0, which is number 2, and the lower bound simply needs to be to the left of the intersection I'm looking for. So I'm looking for this x-intercept, or this intersection, so I move my crosshairs to the left of that as my lower bound. My upper bound, I now need to move it to the right of that. Oops. Hold on, I hit the wrong button. Okay, so if I want to find my 0, my lower bound is just something to the left. Hit enter. Now I move to the right for my upper bound. As long as it's to the right of this intersection, I'm okay. So now my crosshair is to the right of that intersection. And it's going to give me the intersection, or the 0 between those, which is -4, 0. So those would be my two x-intercepts. Now, there's another way to find all the x-intercepts all at once, which is the way I would probably encourage you to use this. And that is, if you have your equation entered in the y-editor, just go to your home screen, use the solve feature, F2, the algebra tab, select solve. And since you've already entered this as the y1 of x function, just pull up access that function using the generic form y1 of x, set it equal to 0, and then solve for what values of x would make this function equal to 0. That's what it means when it's saying the x-intercepts. So just by typing that in, so as long as I type in solve y1 of x equals 0, comma x, I will get all my zeros, and then I just label them. 0 and -4, zeros to the right, -4 to the left.